8 brands, polycarbonate reinforced with carbon fibers. Are they very similar, or is there any bigger difference between them? Let's find out together. Hello, welcome to my tech farm, to one quite important video, but at least for me, because I will compare 8 PCCF filaments, polycarbonates reinforced with carbon fibers. Originally I had only 5, and then I asked my Patreon supporters if they want me to extend the list, and each filament which got at least 3 votes is included here, so that's why I have 3DX Tech from the USA, Extruder from the Europe, and IMA from the China. This video is not sponsored by any of these brands, but actually this video and the whole channel is sponsored by Polymaker, who likes to support my research activity. Unfortunately, they don't have a PCCF version, they only have regular polycarbonate without fiber reinforcement, but this video is only about the carbon fiber reinforced versions. Here you can see the table with the country of origin, but later I will analyze this table more because I want to talk about the price, printability and similar. In most cases these are not pure polycarbonate filaments. It will be very hard for printing. Usually there are some brands, and in most cases I can see that very often they use a PC-PBT blend. Carbon fibers is very important here because it will increase the rigidity, temperature resistance, but very important, the printability, less shrinking and more dimensional accuracy, because pure polycarbonate is extremely hard for printing, and the 3DX Tech and IMA was too hardest for printing. Maybe they are closer to the pure polycarbonate, I'm not sure. And when I finish this video, I want to choose maybe 2 strongest PCCF filaments, and I want to compare them in a direct comparison video with the PET-CF. If I need some stiff, rigid part, which budget-friendly technical filament to use. Of course, PPA, PPS is stronger, but those are very expensive filaments, and these are budget-friendly compared to those filaments. And always I'm very curious in direct comparison, is it PCCF or PET-CF better filament? The most important part in this video will be the mechanical testing, and I printed all test objects already. I'm collecting them several months now, and also I printed these open end and box end wrenches. It will be a nice test for the practical application, but of course I measure other things too. It will be a temperature test. Of course, very important is brittleness of the filament. It will be a huge difference. Some of them are not brittle at all, but some of them are extremely brittle, and they may break in Teflon tubes on some printers. Let's see the filaments: 3DO PCPBT CF, 3DX Tech Carbon X PCCF, Ednord PC Blend HT LCF, Extruder DuraPro PCPBT CF, IMAI CFPC, Filament PC Blend CF, Spectrum PCCF, and YX Polymer PCCF. 3DO start angle 20 degrees. No break at all. Start angle 22 degrees. Around 95. Start angle 25 degrees. Approximately 90. This is moderately brittle. Extruder start angle 25 degrees. No break. IMAI, also not brittle. Filament start angle 25 degrees. Around 110. Start angle 22 degrees. Now it was broken. I will check the footage. Start angle 25 degrees. Around 80 maybe. From this list, the most brittle filament. I collected some information, so these are the brands, and this is the name of the filament, and some additional comments if I bought it or it is from the review video, country of origin, and I try to collect here the prices. Only here it's not clear. For that nor they have some summer sale, but usually it is 125, which is the most expensive. and how easy it is for printing. As already mentioned, that 3DX Tech and IMAI is the hardest for printing. This was harder because it really needed a lot of drying, and this one is very brittle. Now the maximum recommended print temperatures are very different, and I use these temperatures for my printing. This is the hottest and this is the coldest, and the brittleness, as you can see, huge difference between them. Somewhere there is no break. Usually these are some PBT PC blends, and for example, YX polymer is the most brittle. It may have problems in some printers. As you can see from brittleness, from price, temperatures, these are very different materials, but they're all sold like PCCF filament, so that's why I need this testing for myself too. Let's see the test objects in the slicer. I have two plates. This group will be printed with every material, using the same settings except modifying the temperature. And the second plate is only for those older materials where I don't have this bending and impact test on my newer test equipment. Let's take a closer look of this group. They are all solid inside except this one for the layer adhesion. It's printed with 2 watts and 20% rectilinear infill. This is for the temperature test, where the load will be only its own weight. Also for the temperature test, but load will be 0.5 megapascals. This is for the tensile test, and they're longer because I want to measure some kind of prolongation too on my universal testing machine. A simple hook, S hook for the elimination test. I will pulling them and always the weakest will fall out, and at the end we will get the winner. And this is for the creep test. Currently I'm not sure about the load, but I want to vary it. I don't want to use 1.25 kilograms as typical in my testing. Let's measure the shrinking. The length of this test object is 77 millimeters. 3DO 7665. 3DX Tech 7694, but I believe that it has more shrinking, only it's not completely dry filament and it has some over-extrusion. Ednord 7685, Extruder 7666, IMAI 7672, Filament 7684, Spectrum 7687, YX Polymer 7689. Biggest shrinking I could measure with 3DO and Extruder, and these are the only two filaments which have the PBT in the name too. IMAI is also close to this shrinking, but I'm not sure is it also PBT blend. Smallest shrinking I could measure with 3DX Tech, but from this top surface I can see it is over-extruded, so maybe this smallest shrinking is partly a result of the over-extrusion because it is not fully dried filament, I'm not sure. Looks like for the PCCF filament approximately 0.2% is realistic, and just for comparison, regular ABS has a shrinking of 0.5%. Last time in that PCABS video, I got several comments that you really liked my creep test inside the car. Well, it's still summer here, so let's repeat that. The load will be again 1.25 kilograms. The maximum temperature I'm not sure, maybe a little bit above 50 degrees Celsius, but I will measure it exactly on the location of the test objects. The order is not important, but they are all labeled. And the setup, this rod is between two seats. These are the loads, and I will measure them, but off camera. I just don't have a good position for the camera. This is Ednord. They are all measured. There is a huge difference in initial deformation. And this is the position of the thermometer. It will record the peak temperature. I even opened the top window, so the heat will be even bigger. So far the smallest deformation is on the Ednord and the biggest on the IMAI. There is a lot of parking place and I could find some in the shadow too, but it will be exposed to the direct sun. Sorry, only for today. And I will measure them again at the end of my workday in approximately 5 hours. It was not super hot day today, 32 degrees Celsius maximum, but let's see what was the peak in the car. $55.8. This temperature is not big for these materials, but I can see some differences. For example, YX Polymer and Extruder, they had very similar deformation, but now much bigger creeping and deformation I can see on the Extruder. And currently the biggest deformation I can see on 3DO, bigger even from the IMAI. They are all measured, but before the graph, let's remove the load. Actually now they are very similar, maybe a little bit bigger deformation I can see on the extruder and on a 3DO. Sorry about this torture, no more high temperature creep tests this summer. The blue is initial deformation, distance between two reference surfaces, and with orange after 5 hours, and the difference between two in percentage is the creeping, and we can see two biggest creeping on 3DO and extruder. Again filaments with the PBT even in the title, and all others are very similar but still the smallest creeping with the 3D Tech and YX polymer. Layer adhesion test objects, and I prepare them, they will be tested in the correct order. Average from 3, and on the left side you can compare to previous numbers. The strongest is 3DO in this case, but extruder, plus cement, YX polymer are also good. And far the weakest is the spectrum. What is interesting that this was printed on the highest temperatures. In the review video I was experimenting a little bit with the other temperatures too, but I still couldn't got a really good layer adhesion from this material. Tensile test first for materials. And now the results for the 3DO, 3DX Tech, Ednorth, extruder. Next for materials. And again results, IMAI, plus cement, spectrum, YX polymer. Now the most hated part, cleaning. But let's see the graph. The result, average from 3 in newtons, but also I calculated here in kilograms. This is the elongation in millimeters and I calculated in percentage, but it's a little bit suspicious. I have too many repeated numbers. Maybe this is because of the rounding steps multiplied with some numbers, I'm not really sure. I will leave it here, but I will actually not use it. And we can see that the farthest strongest is the Ednorth and the weakest is IMAI. Bending test, first two materials. 3DX Tech broken earlier. This is speed up video of course. And 3DO completely bended. Next two materials. Ednorth broke earlier. A little bit later extruder. Next two. Plus cement broke earlier. IMAI bended. And last two. Both broken. And this is the result for first two. Next two. But I will show them on the graph soon. I just want to include the results. The bending strength is calculated from the maximal load, so that's why only this one is presented on the graph. And we can see two strongest are 3DX Tech and Ednorth. Now elastic modulus, it depends from the deformation too, and here Ednorth is the strongest, but the three weakest are 3DO, extruder and IMAI. Sharp impact test, first two materials, next two. Pay attention, IMAI incredibly tough. And last two materials, similar brittleness. And again I want to include all the results shortly. You can skip this part, I will show it on the graph too later. And now Izod impact test. First two materials. Second two. And now pay attention to the IMAI. Very tough. And last two materials. And a few seconds just to show the results. Very quickly Ednorth, IMAI, YX polymer. With blue we can see the result for the Charpy and with orange for the Izod test. And usually I'm getting very similar numbers, except if the material is tough. In that case usually I'm measuring bigger numbers with the Charpy test, but these are two different types of the test, not really comparable to each other. But anyway we can still see that the IMAI is far the toughest. tougher even from the average ABS, which is very rare for the carbon fiber reinforced materials. Second toughest is 3DO, and from these 8, the most brittle is Ednord. Hook test, I will show you 4 at the same time. Ednord. This time the difference is not big. The standard deviation is approximately 3.5 kilograms, but still 2 weakest are IMAI and the Spectrum, and let's say 3 strongest are 3DO, 3DX Tech and Ednord. The elimination hook test. IMAI fallout. Spectrum is broken. And now the Filament is broken, but I have a problem because 3DX Tech and Ednord fly away and I cannot find them, so this is the end of this testing. 2 pieces flied away, I could find them only next day, but now I have my secret weapon. .3DX Tech is broken. YX polymer is broken. Extruder broken. Ednord is broken, and the winner is 3DO. This is the final order. I'm forcing this test because it may look good in very slow motion and without that acrylic pipe, but in that case they fly away and objects may be damaged from the previous pulling, so it's not really accurate, and I think I will stop doing this in my future testings, and I think I will not use this information in this evaluation. The first temperature test without load. Actually the only load will be their own weight. Objects are tilted, so they will start to deform in the same direction. This oven thermometer is here just for approximate temperatures. It is accurate, but it has some delay. YX polymer Spectrum started to deform first, then IMAI, and then huge jump. This is time-lapse video, but there is no change in the speed, so you can see how big is the difference between them. And complete winner is the Ednord. Almost in original shape. Second temperature test. The load is 50 grams, and on this distance and cross-section, the stress is 0.5 megapascals, and this time the behavior of the materials is very different. Just one example. Filament started to deform before 3DX Tech, but then it slowed down. 3DX Tech started to deform very suddenly and deform completely, so maybe I will have 2 evaluations here, but one thing is obvious, the worst is YX polymer and the best is Ednord. 3DO, extruder and Prusa looks very similar from another angle, and these 3 are similar. Just one more time to explain you what I'm talking about. Pay attention to the Filament. It will start to deform quite early together with IMAI, but then it slowed down with the deformation. And pay attention to the 3DX Tech. For example, at this moment, only these 2 didn't start with deformation. But when it starts to deform, it will deform very quickly. So that's why I will have 2 evaluations here. One is for the start of the deformation, and the other is the complete deformation. Deformation order for the first test, no load. This is the maximal deformation, and this is start of the deformation. This is what I was talking about. Here we can see big differences, for example with the 3DX Tech. But anyway, one thing is clear. The weakest is YX polymer, then Spectrum, IMAI, and far the best is the Ednord. This is almost in the range of some nylons. It's time for the wrench test, and I'm starting with open end. Pulling until the break, and I'm measuring the torque in Newton meters. 3DO 1.8. 3DX Tech 3.4. Ednord 3.4. Extruder 2.5. IMAI 2.1 Filament, 2.9 Spectrum, 2.0 Elimination of the walls, YX polymer, 3.6 broken. And now box and wrench, 3DO, 3.5, 3D X-Tech, 4.1 Ed North, 4.9 broken, extruder, 3.4 broken, IMAI, 2.7 broken, Filament, 4.0 Spectrum, 3.1 YX polymer, 4.0. Let's see them on the graph. Well, the strongest in this test was Ed North. Then 3DX Tech, Filament and YX polymer very similar, but two weakest are the IMAI and the Spectrum. Now the 3DO open wrench was weaker because it deformed, it is more flexible and slip from that holder. I collected here most important properties. For example, if you are looking the printability, then I recommend these four. If you need stiffness and rigidity, far the best was the Ed North and weakest IMAI. Gripping, two weakest are 3DO and extruder. Others are more or less similar, but still the best, the 3DX Tech and YX polymer. Tensile strength, again Ed North is the best, IMAI weakest. Layer adhesion, again no big difference, but still these four are the best. And far the weakest was the Spectrum. Impact strength, far the best was the IMAI, incredibly tough material. And the most brittle was the Ed North. And heat resistance, again, far the best was the Ed North, almost like some PA or nylons, and these three are three weakest. I know it's a long video, but imagine how long was the testing and video editing. And looks like those guys at YouTube team didn't really start with 3D printing yet. Otherwise, maybe they would find some values in my videos. I'm really good with the numbers, and recently I got access to some other channel analytics, and I have the feeling that the algorithm is controlling the growth of small and mid-sized channels by limiting their recommendations in most cases. I mean, if somebody starts to watch my videos, he will get recommendations about my new uploads, but my problem is that in most cases, when I upload new video, it barely gets new subscribers in most cases. I mean, it will be recommended only to those regular viewers or who enable that notification bell button. And this will be so frustrating, but huge thanks to all my Patreon supporters because they keep the faith in me. I mean, without them, it would be very minimal activity on this channel. And thanks to them, I decided to disable the ads during the video. I don't need those extra 25%. About these PCCF filaments. Well, there is a big difference between them, much bigger than between the ABS and ASA from my earlier similar videos. I think the reason for this are different blends or different ratio inside those blends, and it is good to know about them, so I really needed this video for myself too. What's your opinion? Are you using PCCF filaments? And I hope you will follow me to one of my next videos, which will be PCCF versus PETCF comparison, because I want to decide to find out which is the better filament type if I need some budget engineering filament. I hope you will follow me to that video too. Until that, well, thank you for watching this video, and as always, happy printing!